So let's do some more problems, since there's going to be a lot of variety with these different factoring techniques. So if we rewrite this, we have p of x is 2x squared plus 7x plus 5 times x minus 3. Well, just looking at this, we know that if we set this equal to 0, that one of the zeros is at x equals 3. Since if you plug in 3 here, you'd have 0 times whatever this evaluates to when you plug in 3, but 0 times anything is 0. But we need to figure out when this quadratic expression would equal 0. And to do that, we can factor it. Now, this one's a little bit harder since we're going to have to use the grouping method. So let's take a look at this kind of off to the side here. We'll have 2x squared plus 7x plus 5. If the coefficient on x squared is not 1, you want to use what's called the grouping method when factoring these. There are other ways to do this, but grouping is probably the most straightforward. And essentially, we're going to break up this middle term here, this plus 7x, into two separate terms that we can then pair with this first term here, and the other one will pair with this constant term here, and we can use the grouping method to factor. So to determine what we break this up into, well, let's say we're going to break it up into ax plus bx. So we're just looking for those coefficients, a and b. And we know that they're going to recombine to give us 7. So they have to add to 7. But the other condition is that these two numbers are going to have to multiply to the coefficient on x squared and the constant term. So it's their product. So the product of 2 and 5, which is 10. So these two numbers multiply to 10 but add to 7. So let's write out a list of numbers that multiply into 10. That could be 1 and 10. It could be 2 and 5, but it could also be the negative versions of these, minus 1 and minus 10, and minus 2 and minus 5. But they're adding to a positive number, so you can eliminate the negative choices. And they have to add to 7, and you can see that 2 and 5 would both add to 7. So let me make a little bit more room. This quadratic now, we can rewrite it as 2x squared plus 2x plus 5x plus 5. All we did is rewrote this 7x as two different terms added together. But you can see that these are equivalent. Now from here, we'll use our grouping method. We will group the first two together and the last two together. And we're essentially just looking for a common factor. So notice each of these are divisible by 2, and each of them are divisible by x. So we can factor out a 2x. And from here, well, we factored out the 2, and we took away one of the x's, so we just have one left. And this one, we factored out everything. Or remember, factoring is just division. So we took 2x and we divided it by 2x. Something divided by itself is always equal to 1. And this can often be the most confusing one when you're, or I should say the most confusing case, when you're factoring using the greatest common factor. A lot of students think that you should put 0 there, but 0 wouldn't make sense because when you check this, you remultiply, you redistribute, and you still need to get back at 2x here, and 2x times 1 is 2x. If you plug a 0 in here, 2x times 0 is 0, and you would lose this term. So be careful with that one. And from this one, it looks like each of these are divisible by 5, which we can factor out. So we're essentially dividing each of these by 5, and here we just are left with an x, and here we're left with 1. And notice, if you're doing the grouping method correctly, you should end up with the same expression in the parentheses. And then from here, notice that this term and this term share x plus 1 as a common factor, which we can now factor out. So we're essentially dividing each of these terms by x plus 1. When we do it here, the x plus 1's cancel, and we're left with 2x. And from here, the x plus 1's cancel, and we're left with plus 5. And to check this, just re-multiply it out using distribution, which I would recommend doing since this method is a bit complicated and a little messy. So at the end, you want to re-multiply it out and prove to yourself that you get back this starting quadratic. But in this case, it would work if you do multiply it out. And At this point, we've just figured out how to factor this quadratic into two different binomials. So we can rewrite our polynomial as x plus 1 times 2x plus 5, that's this quadratic expression, times by x minus 3. And we're trying to figure out the zeros, so we can set it equal to 0 and figure out which x values would make this true. So again, we're using our zero product property. So for us, if we use 3 here, like I mentioned earlier, 3 would work. If we use -1, that would work as well. And for the more complicated ones, you can just set those equal to 0 and then solve. And what you'd find is that x is -5. If we subtract 5 on each side and then divide by 2, x would be -5/2. So that is our third of the zeros for this cubic polynomial. And at this point, we just need to plot these. So 3 minus 1, and this is -2.5. So we're at +3, -1, and -2.5. And again, eventually you will learn how the graph will move through these points and how the graph will essentially end. But for now, we just need to figure out these zeros.